Let's take a look at this example. First, like always, we're supposed to redraw the diagram. Anytime you see 10 volts, it means that we have DC power supply connected, right, to the circuit by the positive terminal, okay, to the positive terminal, because we have no sign over here. No sign means this is invisible positive, okay? So this is my voltage source, which has 10 volts, okay? So I can erase this 10 volts from here. Next, I'm supposed to look, right, in which direction current is going to flow. Voltage source is going to push the current from positive terminal to negative, okay? So theoretically, my current has to flow clockwise. So this is going to be my I total. Next, you're supposed to look at the direction of current, and you're supposed to look at the direction of arrowhead of the diode symbol. I mean silicon diode and germanium diode. Please notice that the arrow, right, points in the same direction as the arrowhead of the silicon diode and arrowhead of the germanium diode, and the voltage source is greater than, in this case, 1 volt, because 0.7 plus 0.3 is like kind of minimum which we're supposed to have in order to make this circuit working. So if I have 10 volts, so for sure the diodes are going to pass the current, they are in the on state, okay? So what we're supposed to do next, we have to look what we're supposed to find. We have to find Vout1, Vout2 and ID. Please notice that Vout1 is the voltage measured from this point to ground. We do not have any resistors on the way from this point, Vout1, to the ground. So it means that we can determine the output voltage 1 without any extra calculations. What I mean by that? Remember that anytime current is going to enter any component, we're supposed to put positive sign. Anytime current is leaving, we're supposed to put negative. We have positive, negative, and I have positive, negative. Next, we're supposed to use the KVL, right? And write the equation for the output voltage 1. So what I have, Vout1 is equal negative voltage across the silicon diode, okay? Okay, so this is my VD across the silicon diode, which is equal 0.7, okay, don't forget that. So I have negative V silicon, and I have plus, okay, because I'm going to the ground, I have positive voltage source. Okay, one more time, I have negative voltage across the diode plus voltage source. So this is equal negative 0.7 volts, because this is the transition voltage at the silicon diode, plus 10 volts. This is equal 9.3 volts. Okay, so this is the voltage at this point. Okay, this is my Vout1. If you want to find Vout2, Vout2 is nothing else, just the voltage between terminal Vout2 and ground. Please notice that output voltage 2, right, second output voltage, is going to be taken across the germanium diode. We said that both diodes are forward biased, and when the germanium diode is forward biased, in other words, is in the on state, is going to have transition voltage equal 0.3 volts. So it means that we're going to measure 0.3 volts across the diode, and this is going to be also my output voltage 2. Okay, so V out 2 is equal VGE, which is equal 0.3 volts. Next, the problem is asking us to find the current. Okay, remember, anytime we're looking for current in this kind of circuit, we're supposed to use Ohm's law. We have to find the voltage across the resistor, right? Because current is equal voltage over resistance. So we can write that VR is equal, and we have what? V out 1 minus V out 2, okay? The difference of these two voltages is going to give me voltage across the resistor. So I have V out 1 minus V out 2, where V out 1 we found is equal 9.3 volts, and V out 2 is equal 0.3 volts minus 0.3 volts. Everything is equal 9 volts. It means that the voltage across the resistor is equal 9 volts. So if you want to find the current, as I said, use Ohm's law. I total in the circuit, I can say, is equal to I silicon is equal also I germanium. This is also equal IR. Okay? Why? Because this is series circuit. In series circuit we have just one current. So we can say this is also equal to ID, where ID represents the current which goes through silicon diode, and ID also represents the current which goes through the germanium diode. Okay? Sometimes in the problems you see find ID, so the current which goes through the diodes, okay, in the series circuit in this case. Okay, so how we can find the current? Simply divide the voltage across the resistor over the resistance. So VR is equal 9 volts over 3.2 kiloohms. This is equal 2.81 milliamps. Okay, so this is the current in my circuit, right? So as you can see, we basically found everything, whatever the problem was asking us to find. We can say that the problem is solved.